Ram had an all-electric pickup ready to fight Ford, Chevrolet, Tesla, and everyone else chasing the electric truck market. Then Stellantis canceled it, not delayed it, not softened the launch. The pure battery truck was pushed aside, and Ram redirected its attention toward a machine built around a very different idea. Let the battery handle normal driving, then let a gasoline engine generate electricity when that battery runs low. A 92 kilowatt-hour battery, roughly 145 miles of electric range, around 690 miles of total range, and as much as 14,000 pounds of towing capacity. It sounds like a new answer to the electric truck problem, except General Motors had essentially solved this problem a decade ago. In fact, an American car using the same basic philosophy earned an official efficiency figure of 106 miles per gallon equivalent, could cover most daily driving without gasoline, and could still travel more than 400 miles without depending on a charging station. Chevrolet sold it beginning years before electric vehicles became the center of the auto industry's strategy. Then GM killed it in 2019. That forgotten car was the Chevrolet Volt. And the strange part of this story is not simply that its idea survived. The strange part is that in 2026, after billions of dollars in electric vehicle investment, automakers are rebuilding versions of the concept they once treated like an evolutionary dead end. And Ram's reversal may be the clearest evidence yet that Detroit's supposedly inevitable electric future is turning into something much more complicated. To understand why, start with a number that recently traveled around the automotive world: 106 miles per gallon. In April 2026, Chinese automaker Geely drew enormous attention after certifying an engine with a thermal efficiency of 48.41% and completing a Guinness World Records verified hybrid run using only 2.22 liters of fuel per 100 kilometers. Converted into a number familiar to American drivers, that is roughly 106 miles per gallon. The result was impressive enough on its own. The Toyota Prius, famous for squeezing extraordinary distance from a gallon of fuel, managed roughly 93 miles per gallon in a comparable efficiency run. Geely went farther. Headlines treated the achievement as another sign that Chinese automakers were moving beyond cheap manufacturing and beginning to challenge the West at the most fundamental level of automotive engineering. The engine itself appeared to be entering a new era, but 106 is also a strangely familiar number, because more than 10 years earlier, the United States government had placed that same figure on the window sticker of the Chevrolet Volt. The comparison is not perfectly identical because the Volt's rating was miles per gallon equivalent, which incorporates electrical energy rather than measuring gasoline consumption alone. But the deeper connection matters more than the sticker arithmetic. Both vehicles attack efficiency through electrification without requiring the driver to depend exclusively on a giant battery. And the Volt had already demonstrated how powerful that architecture could be in ordinary American life. The second-generation Volt, sold from 2016 through 2019, carried a battery large enough for about 53 miles of electric driving. For many commuters, that meant the gasoline engine could remain off for the entire workday. GM said around 90% of Volt trips were completed using electricity alone. Plug it in at home overnight, drive to work, run errands, return home, and repeat. You could operate it almost like a battery electric car. But when those 53 miles were not enough, the vehicle did not become useless. A 1.5-liter gasoline engine entered the system and helped generate the energy needed to keep the electric drivetrain moving. Depending on operating conditions, the Volt's powertrain could mechanically assist propulsion as well, so describing it as nothing more than a generator is an oversimplification. But from the driver's perspective, the experience delivered the important part of the range extender promise. Electricity handled the short trips. Gasoline eliminated the fear of running out of battery on the long ones. Total driving range exceeded 400 miles. One reviewer covered 106 miles while using about 1 gallon of gasoline plus roughly $1.50 of household electricity, putting the entire trip near $3.50 at the energy prices used in that test. Think about what that meant in 2016. No national fast-charging network approaching today's scale. No need for a 100 kilowatt-hour battery. No complicated road trip charging strategy. If your normal day stayed within the battery range, the car behaved electrically. If you suddenly needed to travel 500 miles, you simply kept driving and refueled in minutes. The Volt started around $34,000, won major awards, proved the technology in actual customer hands, and still disappeared. So why would General Motors retire a vehicle that now looks like a preview of the industry's newest strategy? Because in 2018 and 2019, the Volt's greatest strength was also becoming its biggest image problem. The automotive industry was falling in love with a much cleaner story. Tesla was growing, battery prices were falling, investors were rewarding electric vehicle announcements, and executives increasingly described the future in absolute terms. Batteries would get cheaper, charging infrastructure would spread, range would increase, internal combustion would fade away. Under that logic, anything combining gasoline and electricity looked temporary. The Volt was not fully electric, so it could be portrayed as a bridge toward the future rather than the future itself. It also had practical disadvantages. It was relatively expensive for a compact car, while American buyers were moving rapidly toward crossovers, SUVs, and pickups. Chevrolet was trying to sell sophisticated propulsion technology inside a body style the market increasingly did not want. GM discontinued the Volt, ended production at the Detroit Hamtramck plant in early 2019, and redirected resources toward a dedicated battery electric strategy. At the time, the decision had logic behind it. If battery-only vehicles really were going to become cheaper, easier to charge, and universally desirable within a few years, why keep investing in the additional complexity of carrying both a battery system and an engine? But then the market began answering that question. Electric vehicles absolutely grew, improved, and became mainstream enough that almost every major automaker had to take them seriously. Yet adoption did not move in the straight line many corporate plans assumed. Charging remained uneven, especially away from major cities and interstates. Upfront prices remained a barrier. Apartment dwellers often could not charge at home. Cold weather reduced range. Long trips required more planning. And electric pickup trucks exposed an even more difficult problem. Towing a heavy trailer can dramatically reduce battery range. Increasing battery size can recover some of that range, but a larger battery adds cost and weight, which then creates another engineering penalty. The truck segment magnifies every weakness because owners expect vehicles to tow, haul, travel long distances, operate in remote areas, and refuel quickly. Suddenly, the supposedly awkward compromise that Detroit had dismissed started looking less awkward. Put enough battery in the vehicle to cover most normal driving, but stop trying to make that battery solve every possible use case. Carry a compact engine as an onboard energy source for the moments when batteries are least convenient. That brings us back to Ram. The company's original strategy included the battery electric Ram 1500 Rev V, but Stellantis later canceled plans for the fully electric pickup as demand expectations changed. The vehicle now receiving enormous attention is the Ram 1500 Ramcharger, a range-extended electric pickup. Its battery powers electric motors that drive the truck, while a 3.6-liter Pentastar V6 can generate electricity when additional energy is needed. The scale is completely different from the Volt because this is a full-size pickup. Ram has discussed approximately 92 kilowatt-hours of usable battery capacity, about 145 miles of targeted battery electric driving, roughly 690 miles of projected total range, and towing capability reaching around 14,000 pounds. The Volt was trying to make an efficient compact car practical. The Ramcharger is trying to make electrification compatible with the hardest jobs pickup owners ask a vehicle to perform. Yet the strategic philosophy is remarkably similar. Do not force the battery to handle everything. That philosophy is spreading. Scout Motors, the Volkswagen-backed American brand building a factory in South Carolina, plans electric trucks and SUVs while also offering a range extender option called Harvester. The battery still drives the electric motors, but an onboard gasoline engine can generate additional electricity. Scout leadership has said a large majority of reservation customers have selected the Harvester configuration, with figures around 80% or higher discussed publicly. Whether every reservation eventually becomes a sale is another question, but the preference is impossible for automakers to ignore. Buyers interested enough to reserve a new electric-oriented truck brand are still overwhelmingly asking for the version with a gasoline safety net. Ford has also discussed extended-range electric architectures for future large vehicles. Stellantis has signaled more electrified combinations across its portfolio. General Motors itself has announced plans to bring plug-in hybrid technology back to North America, targeting introductions beginning around 2027. Nissan continues developing its e-Power strategy, where gasoline engines generate electricity for an electric drivetrain in several markets. China has moved even faster. Range-extended vehicles have become an important part of the market there because they allow electric daily driving without making long-distance mobility completely dependent on public charging. The industry has not returned to one exact mechanical copy of the Chevrolet Volt. The architectures differ. Some are plug-in hybrids, some are series hybrids, some allow mechanical connections between the engine and wheels. Some use the engine almost exclusively as a generator, but strategically, they all reflect the same reversal. The question is no longer simply gasoline or batteries. Automakers are rediscovering that combining the strengths of both can solve customer problems that ideology cannot. And this is where the engine itself becomes more interesting, because electrification does not necessarily make combustion engineering irrelevant. It can actually give an engine an easier job. A conventional engine has to operate through an absurdly wide range of conditions: crawling through traffic, accelerating from a stop, cruising at 70 miles per hour, pulling a trailer uphill, idling at a traffic light, maximum power 1 minute, minimal load the next. Engineers can optimize an engine around certain operating points, but normal driving constantly pulls it away from those points. An engine used primarily to generate electricity can be treated differently. The battery absorbs sudden changes in power demand. Electric motors respond immediately to the driver's accelerator. The engine can run closer to the speeds and loads where it converts fuel into useful energy most efficiently. Instead of following your right foot second by second, it can operate more like a compact power station. That matters because internal combustion still wastes enormous energy as heat. Typical automotive gasoline engines may convert roughly a quarter to a third of the fuel's chemical energy into useful mechanical work under many real-world conditions, while the rest disappears through exhaust, cooling, friction, and other losses. Engineers have spent generations attacking those losses. Achates Power in California revived an opposed piston architecture using 2 pistons inside each cylinder moving toward one another, eliminating the conventional cylinder head and changing how combustion and gas exchange occur. Demonstration engines from the company have reported brake thermal efficiency approaching or exceeding levels around 50% under certain configurations, and the technology has been tested in commercial vehicle applications. Cummins and research partners have pushed heavy-duty diesel efficiency beyond 50% through advanced combustion, turbocharging, waste heat recovery, and other systems. Mainspring Energy went in an even stranger direction with a linear generator that replaces the familiar rotating crankshaft arrangement with a reciprocating design that directly produces electricity. These technologies are not all destined for passenger cars. Some are better suited to trucks, stationary generators, military applications, or data centers. But notice the common thread. Once the objective becomes generating electricity efficiently rather than mechanically connecting every combustion event to the wheels, engineers gain new freedom. The drivetrain becomes modular. Electric motors handle propulsion. Batteries handle transient demand and regenerative braking. The combustion device can concentrate on converting fuel into electricity at an efficient operating point. That is why the current range extender movement is not simply an admission that charging networks are incomplete. It creates an opportunity to redesign what an engine is for. Several technologies had to mature before this became practical at scale. High-pressure direct injection improved control over combustion. Better electronics allowed engines and motors to coordinate with extraordinary precision. Electric traction motors became powerful, compact, and reliable. Lithium-ion batteries dropped massively in price compared with early electrified vehicles. Those batteries do not need to provide 300 or 400 miles of range in a range extender. They only need to cover enough daily driving to make the engine unnecessary most of the time, while also acting as an energy buffer when the vehicle demands sudden power. That changes the economic equation. A huge battery is expensive and heavy. A tiny battery means the engine runs constantly. Somewhere between those extremes is a configuration that can cover the majority of daily miles electrically without forcing the owner to accept the weaknesses of either system at its most extreme. The Chevrolet Volt demonstrated that formula in a compact passenger car when batteries were much more expensive than they are today. Ram is now applying a related formula to a pickup because pickups reveal exactly where pure battery solutions can become difficult. Imagine 2 owners. One commutes 35 miles per day, plugs in every night, and tows a large trailer only a few weekends per year. A pure gasoline truck burns fuel during every commute just so it can be ready for those occasional towing days. A giant battery electric truck carries hundreds or thousands of pounds of expensive battery every day, partly so it can attempt those same occasional long trips. A range-extended truck offers a third calculation: carry enough battery for the routine, carry a generator for the exception. During commuting, the owner could potentially use almost no gasoline. During a 600-mile towing trip, the vehicle still has access to the existing fuel infrastructure. That is the attraction. It does not mean range extenders automatically win. They have disadvantages too. You are carrying two energy systems instead of one. That adds components, packaging challenges, maintenance considerations, emissions hardware, and cost. A driver who already has reliable home charging and never tows long distances may be better served by a pure EV. Someone who rarely plugs in could end up carrying an expensive battery while operating mostly on gasoline, defeating much of the efficiency advantage. And a conventional hybrid may be cheaper for buyers who do not need extended electric range. There is no universal winner. That may actually be the lesson Detroit missed the first time. The mistake was believing there had to be one. The Volt arrived when the industry wanted a clean transition story. Gasoline first, electric second, with hybrids existing only as a temporary bridge. Reality is refusing to follow that script. Different buyers have different garages, climates, commutes, trailers, budgets, charging access, and tolerance for inconvenience. A technology can be imperfect as an ideological endpoint and still be excellent as a product. The Volt may have been exactly that. It was not proof that pure EVs were unnecessary. It was proof that electrification could dramatically reduce gasoline use before batteries and charging were ready to handle every journey. GM removed it at the moment when that nuance became unfashionable. 7 years later, Ram is making almost the opposite calculation. Instead of asking how quickly it can eliminate the engine from the truck, it is asking whether an engine can make an electric truck more useful. That is an extraordinary reversal, and the irony becomes sharper when you remember where we started. A Chinese automaker captures global attention with an ultra-efficient electrified powertrain and a 106-mile-per-gallon headline. American manufacturers are canceling or reshaping battery-only programs and introducing vehicles that rely on electric motors while keeping combustion on board as an energy source. Meanwhile, used Chevrolet Volts are still quietly driving around with a technology strategy the industry once decided had no future. GM did not fail because it lacked engineering talent. The company successfully placed the idea into customer hands years ahead of the current rush. The failure, if you consider it one, was strategic confidence. Detroit believed it knew which part of the transition was temporary and which part was permanent before customers had finished answering the question. Now customers are answering. They want electric driving without electric restrictions. They want efficiency without planning their lives around a charger. Truck buyers want torque and quiet operation, but they also want to tow into places where a charging station may not exist. Automakers can argue about which technology deserves to win. Buyers care whether the vehicle works on Tuesday morning and Saturday afternoon. That is why Ram's decision matters beyond one pickup. It signals that the next phase of electrification may be less about replacing every engine and more about changing the engine's role. The engine that once dominated the drivetrain becomes backup infrastructure carried inside the vehicle. It may run occasionally at optimized conditions, generating energy while electric motors do the actual driving. In that world, batteries and combustion are not enemies. They are assigned different jobs. And strangely enough, Chevrolet showed everyone what that could look like in 2016. The Volt was killed because it appeared to belong to a transitional era. In 2026, the transition is starting to look a lot more like the Volt. So was General Motors wrong to cancel it? Or was the company simply too early for customers to understand what they had? And if you were buying a truck tomorrow, which compromise would you choose? A pure EV with a larger battery and no engine? A traditional gasoline truck with familiar refueling? Or a range-extended electric truck that tries to combine both worlds? Put your choice in the comments because the answer to that question may determine whether Ram just revived an old idea or discovered what the next decade of American vehicles is actually going to look like.